All right, 15th time might be a charm. Who knows? Don't even know. Don't even care. I'm getting a little tired of this problem. Every time I start this process, I get screwed up. Unfortunately, you don't get to hear the ice cream truck, which is shaped like a pirate ship, go by, playing the most hideous music ever in this particular version of the video, unless they come back around again. Who knows? So I get this guy here. Oh, plus F, rather. Sorry. Okay. We know that F, we know that it's going to be of the form, right? F naught cosine omega t. That's cool. And we know that we have a particular solution of the format, some c cosine omega t. That's going to be our particular solution. Remember, this is just like before. We have particular solution and we have the complementary solution. The complementary solution is based on what the thing is made out of. In this case, springs and masses. In the case of an RLC circuit, it's made out of, inductors, resistors, capacitors, the whole routine. Obviously, if you change the capacitor, it's going to change how it affects. That only affects, that's how it's made out of, that affects the complementary solution. If you plug it into the wall outlet versus you plug it into a battery, why, they're going to act differently as well. That's the outside, that's the particular solution piece. Note that I'm interested in x double prime. So I'm going to need x double prime. But to get there, I got to go through x prime. Right? Cool. So that's negative omega squared c cosine omega t equals a times that x particular solution, c cosine omega t, plus f naught cosine omega t. It doesn't take a rocket surgeon to see they all have a cosine omega t in common. And your book chooses to solve it this way. Oh, wait, there it is. The pirate ship is now down the street behind my house, and you can now hear it out the back of my house. Crazy idiots. Anywho, these guys have a C in common, so you can factor it out. Not so fast there, homeboy, because this is a constant, like 12 or something. This is a matrix, a 2 by 2 matrix specifically. So we must introduce the I matrix to pull that off, the identity matrix. That's where we get to. Great, awesome, wonderful. Now, a couple things to come to mind. Okay? Two things come to mind, actually. So we're going to use this equation right here in just a moment. Okay? We're going to use that equation there in just a minute for two things, but mostly we're going to use it for finding our solutions for our undetermined coefficients, because that's really what we're going to be doing in a minute with that guy right there. We'll do that in a jiffy. I'm going to keep going with this piece right here if you don't mind. Okay? So, first and foremost of all, okay, we have to take M inverse times K. This is our A matrix. And the eigenvectors and eigenvalues of him are what I'm interested in. Okay, so that's going to be 2, 0, 0, 0.5 inverse times okay, and big dummy, where are you at? Somewhere up here I've got the answer that I was searching for. Oh, for the love of Pete. Well, anyway, it's negative 50. Oh, it's right there, negative 50. The funny thing is, if I was actually dyslexic, I could use that excuse. I'm just an idiot. Why are you using it? There you go. Now, if you find the eigenvalues of that, you will find that they are negative 25 and negative 75. Remember, those are lambdas. That's equal to negative omega squared, which means my omegas are 5 and 5 root 3. Okay? And then if you grab your eigenvectors on this problem, you'll see that they are 1, 2. That goes with this one. And negative 1, 2. Okay, that goes with this guy. Keep that in mind momentarily. Okay? Now, that's kind of a big deal. We know our solution will be of the format, always. We know this. Will be of the format, some C. I'm not going to call it C. Well, C. Nah, I don't want to call it C. That'll freak everybody out. G. Yeah, G. But G. 1, 2. Cosine of 5t plus H negative 1, 2 cosine of 5 root 3t plus, and then what we don't know is we don't know our C1 and C2, which we'll solve for in just a moment, but for cosine of 10t. Okay? This is our particular solution. These guys here will be our complementary solution. Okay, is everyone good on that? Nice. Now, we also know that the initial value of this function, we know that x of 0 is 0. Don't ever let me catch you doing it the way the book does it. X equates these, the derivative and the original function. It's lunacy, friends. Lunacy. Because x would be like saying miles. The derivative would be like in miles per hour. So miles equals miles per hour. Never is that true, sir. Never. That's just lame. They save like a penny the amount of ink or something. So yeah, no, wrong. Don't ever do that. The fact that the derivative is 0 means that there are no signs. Does that make sense? There are no signs in this equation. Okay, and they go away. So if you take the derivative, if you had a cosine and a sine, the sines would become the cosines, and then you'd have something left over. Does that make sense? So there wouldn't be any signs. It has to be entirely a cosine function. Okay? And so hence that's how we know we are where we are. Now, interestingly enough, you can see how this is going to work out. But we need to find C1 and C2 first. So on page 330, it shows how to do this, but I'm going to go ahead and show you. I did it in the calculator. So right here, you see we end up with actually, I don't want to show that. Never mind. Back to train up here. Back to train up here. So if you come up here, I'm going to do it a different way. I'm going to kind of approach it a little differently just to see if I can do this. There's two ways to do it. Okay, so in theory, the other way works. For whatever reason, I am not holding my mouth right on that today. Not even close to holding my mouth right on that deal. It's kind of freaking me out just a lot. Okay, so my A matrix is this guy right here. Are you with me? That's my A matrix. So what I'm going to do is I'm going to use actually this equation right here. That's what I'm going to look at. And so I'm going to have omega squared. So notice that omega squared that's negative 100. Okay. Times C. Are you with me? Okay. Now remember this C here is a vector of C's. Okay. So if you will, a C1 and a C2. You can do it that way, or you can just leave it as C, cool, is equal to, again, A times C. Well, what is A? A is this guy right here, so negative 50, 12.5, 50, negative 50 times C, cool, is E plus. Now, what do we want up here? We wanted plus, where did it go, dummy? F naught. Well, what would our F naught be here, right? Well, that'd be, and maybe it's easier to see this way. It's negative 100 and 0. Okay? Actually, not negative 100, 100 and 0. Okay? Why 100? Because it's on this side. We hadn't solved for it yet. Okay? So if we do this right, that should be nice. Now, this looks kind of gross because we know that this clearly, the way I have it written out right here, this is a 2 by 1 matrix. I'd like this to be a 2 by 1, so I'm going to write C1 and C2 if that's okay. I'm going to write this also as C1 and C2. Cool. Let's do that. So if you did that, then if you FOIL this out, if you distribute this out over here, you're going to have on the top row, you're going to have negative 100 C1. That's going to be negative 50 C1. Plus 12.5 C2 plus 100. And on the bottom, you're going to have negative 100 C1, 2, 50 C1 minus 50 C2 plus 0, obviously. So if a person were solving this, one would see that you could see that it's going to be, I don't know which is easier. I guess let's move that over there. Negative 50 C1 minus 12.5 C2 equal 100. And then I think I'm just going to do 50 C1 and then move this over to here. It's going to be plus 50 C2 equals a goose egg. I think that's good. Now I just not feeling it today, so I'm going to cheat if you don't mind. I don't care if you do, I'm doing it anyway. So solve. Oh, you hippie. Solve negative 50x minus 12.5y equals 100 and 50x plus 50y equals 0. Oops. For x comma y. Oh, gross. Oh, it's not either. Alright, well, let me pause while I check my... It'd help if I had someone in the room to keep an eye on me. It's just 50, Jay, not 850, you goob. Well, what do you know about that? And it's still goofy. God dang it. One moment, please. Anyway, back to this. So when you solve this equation, what you will find is that C1 is equal to negative 8/3, and C2 is equal to positive 8/3. Now you're like, wait, Jay, I did it the way they did on page 330. Okay, cool. Let's do that, friend. Glad you thought of that. So that's going to be x squared minus 50, comma 12.5. It's only the 15th time I've done this problem today, so it's a good time. And you get this mess here. No, cripes. Rather, you get this crap here. Yay! Now, recall the reason that you get this polynomial on the bottom is because you did a determinant, and so the determinant is going to give you that x minus 50 times x. Well, it's going to factor out and do all that stuff, and it comes out to be x minus 25, x squared minus 25 times x squared minus 75 in that denominator. Okay? But look what happens here. If you take this guy here and you evaluate it such that x equals 10, that's our driving force. Boom. There you go. Same answers. Now, what does that tell me? First of all, it tells me that the answer in the back of your book is incorrect on this problem, which really pisses a fellow off when they're rusty at this and you're going, it's weird. But check it out. The back of the book has something like, what do they have for this one? They have, you're like, I'm going to go check myself. That'd be great. They had 4/3 and 16/3. Here's your problem, though, friends. Check it out. If you solve this equation right here, you know that C1 is going to equal negative C2. Therefore, there is no way they can be anything other than what they are. Like in this case, the 8/3 and negative 8/3. You see that? So the fact that the book has opposite answers, not cool. Not cool. Okay? So here they are. I'm going to write them as x1 and x2. And so, as I mentioned, I think previously up here, I think I used G and H. I did. So I'm going to go ahead and do this. But I'm going to go G. I'm going to write it out as G here and 2G here. Cosine 5t, sweet. Cosine 5t, whatevs. The next one is minus H cosine of 5 root 3t. And plus 2H cosine 5 root 3t. And then minus 8/3 cosine 10t plus 8/3 cosine 10t. Nice. Cool. So at 0, what do I get? Well, I get 0 equals, that's going to be g minus h minus 8/3. Correct? And 0 is going to equal 2g plus 2h plus 8/3. Hot diggity dang. I'm going to times the top one by 2 because I can. And 0 is equal to 2g plus 2, or minus 2h. And then it's going to be minus 16/3. If one were to add, one would get 0, one would get 4g, one would get a goose egg, and one would get negative 8/3. And so if you do this, you get 4g is equal to 8/3. That means g is equal to 2/3. Okay. Now, that's the other reason you know there's a problem if you go in the back of the book and start looking at it. Okay. No, it's okay. And actually, never mind. That's fine. Now shut up. So originally I thought this one was the one that was the fifth one. That's a different one. So then if you go 0 equals 2/3 minus h minus 8/3. Okay, well, if you do the math on that, that's going to be, bring the h over here, it's going to be equal to negative 6/3, I believe. Right? And what is negative 6/3? Well, last I checked, it's negative 2. So that means that our top equation is going to be x equals, so it's going to be g, which is 2/3, cosine of 5t, minus h, so plus 2, and then minus 8, well, you dope, sorry, cosine of 5 root 3, and then minus 8/3 cosine 10t, and then for x2, because we have a 2, this is going to be 4/3 cosine 5t, and then we had a they're going to be opposite signs, so minus 4 cosine 5 root 3t plus 8/3 cosine of 10t. There you go. And that's actually goofy because I shouldn't have had the negative there. Well, that should be negative. This is opposite sign of that. There you go. Okay. Yeah. Well, here's what happens. If I put it the way I put it, yes, that makes more sense. Okay, now let's look at this thing here to see what happens. Okay. Well, so if you were to graph those guys in the old Desmos.com, oh brother, where's my key pen? So 2/3. Nice. Okay. And then I'm just going to copy, because I'm lazy, so I'm just going to copy this equation and just change the coefficients. And so they were positive here, and they were positive 4 here, and they were 4/3 here. Nice. And so again, at 0, zoom in a little bit there. Jeez, what a mess. Oops, that's the other way, dummy. All right, so we have small issues that we have. One, oh, because it's supposed to be negative 4. Yeah, see, I did do it right the first time, you jackass. I had it right the first time. But how did I know I was wrong? Because at 0, it's supposed to be 0. And now it is! Hot diggity dang. Anyway, that's the correct answer right there. Okay. Sorry about that. I get a little excited sometimes. Again, they must meet the criteria. The criteria was at 0, it's 0. Bam, done. Finally, I guess that's better.